Okay, let's do some high school algebra for fun. So we're going to factor the following expression. We have x to the fourth power plus some coefficient integers times x to the second power, or x squared, plus 1. So let's start with something that's very easy. Suppose that the coefficients that we have inside the box is positive 2. What should we get? Well, of course, we can just do a quick substitution. Let y be x squared. So now we actually get y squared plus 2y plus 1. And this is a perfect square. So if we try to factor out, we'll get y plus 1 quantity squared. And again, what's y? Y is x squared. So we substitute in and we'll get our answer, x squared plus 1 quantity squared. Good. Now let's do another easy one. Let's say if we are going to change the positive 2 into negative 2, then what are we going to change? We're going to change the sign of the y term, and this is still a perfect square. And if we try to factor out, we now just change the positive to negative. So we end up with x squared minus 1 quantity squared. And of course, x squared minus 1 is factorable. In other words, we can actually make it into two small terms with integer coefficients. So we of course need to factor out in order to complete our answer. So if we break it, this is difference of squares. So we'll actually get the sum of the two terms times the difference of the two terms. Meaning we're going to get x plus 1 times x minus 1 quantity squared, or equivalently x plus 1 quantity squared times x minus 1 quantity squared, like this. So we already did the easy ones. Let's try to do something that is a little bit more challenging. So instead of having plus or minus 2, what if we have something that is a lot different, or something that is a lot bigger? For example, let's say if we just have something like negative 23. I'm going to switch it with this blue pen. Negative 23. How are we going to do this now? Well, it seems like it's not possible to do that, right? However, here is what we're going to do. Keep in mind, we already have two results. If we have positive 2, we can factor out into a perfect square like this, x squared plus 1 quantity squared, where if the coefficient is negative, we're going to get x squared minus 1 quantity squared. Then how are we going to use this to help us? Here is the deal. Here we have negative 23. So we can now consider of breaking it into plus 2 or minus 2, and then we'll have some other things. Why does that help? Well, here we actually need to use the following trick. Besides we have the square of the sum and the square of the difference, we also need to use this formula. A plus b times a minus b is equal to a squared minus b squared. In other words, we need to use the difference of squares to help us factorizing it. And doing so, we now need to get into some quantity squared minus some other things squared. Okay. Then what can we do from here to get down to here? We see that from the two results that we found, we already have the x to the fourth power and the constant term matching. The only term that is not the same as any of the results on the right side would be the x squared term. But luckily, we have x squared, meaning that we can find some nice number or some nice integer which is a square, so that this term, after we put it out, we will somehow be able to get a square of some expression. Then In this case, we see that we actually put out something times x squared. So what we expect to have is here we'll expect to have something times x quantity squared. Okay, now we also know that we want to get the other side to be a perfect square, which in fact will be one of the two expressions that we have on the on the right hand side. So we may expect to get x squared plus or minus 1 quantity squared, where the sign here is actually dependent on the coefficients that we have. We don't know what we should use at this moment. Then what should we do? Well, let's see. Right now we have negative 23. So we might actually need a plus 2 or minus 2. So if we have a plus 2 here, we're going to subtract plus 2, meaning we're going to take the inverse of it. Where if we have a minus 2 here, then we're going to have minus a negative 2, meaning that we're going to add a 2 to the coefficients that we started off with in order to remain the remain the expression the same. Okay, so let's see what we are going to get. So we have two options. Either we're going to have plus 2 or minus 2. Okay, so if we're going to add this, well, we're going to take this and then plus 2, we're going to get negative 21, where 21 itself is not a perfect square. So let's try the other one. If we're going to subtract 2, we're going to have negative 23 minus 2. So we have 23 and 2 adding together to give us 25. Now, if we take away the sign, we now actually get 25, which is actually a square number. Why does it matter? Because now we can try to use this result here and plug it in. So 25 is a square number. In fact, it is 5 squared. So what we want to put here will be the square root of 25, which is 5 here. Then, since we need to have we need to subtract 2 in order to get negative 25, which becomes 5x quantity squared for a second term. We now need to actually take the inverse of it, meaning that if we subtract 2 to get this, we need to add 2 back in the whole expression in order not to change the value of the expression at all. So, in other words, we're going to split the minus 23 into minus 25 and plus 2, where the minus 25 is jumping into our second term. So what we have is the plus 2 is going to combine with our first big term. So we will end up with x to the 4th power plus 2x squared plus 1. And that is equal to our first result. Meaning that if we try to complete the square of that part, we will end up with x squared plus 1 quantity squared. So once we have this, we have difference of squares, so that we can use the formula that we have here to give us the result. And we will you get the answer, x squared plus 1 plus 5x, which is b, times x squared plus 1, that is a, minus b, which is 5x. And this is how we get our answer. So, if we are going to change negative 23 into negative 27, how are we going to switch the answer? Well, since we were still trying to split it, we now actually get minus 25 here. But then if we want to split the minus 27 into minus 25 and some other thing, the other term will now become negative 2. And this will actually make us getting a different result. Instead of having a plus sign here, we now end up with the minus sign. And eventually, we need to change from +1 to -1 to our answer. Great. So there are actually a lot more other numbers that we can do. And in fact, we can actually generalize it into something like this. And perhaps if you look at the thumbnail, you have already aware of what I'm trying to do. So if we're going to have the following expression, we have some, let's see, how should I put it? Plus some negative a squared value, where a is of course integer in this case because we want it to be an integer. And then we have plus minus 2 times x squared plus 1. We can actually factor it out into the following. Using the similar idea that we have, we are now going to split the coefficients of x squared into 2 parts. Negative a squared, and then the other one will be plus or minus 2, depends on the question itself. So that we are now going to get x to the 4th power plus or minus 2x squared plus 1. So this is our first part. Then we're going to add the second part, which is plus negative a squared x squared, or in other words, we will have minus a squared x squared. And now we can just factorize 2 parts separately. First part, if we have plus, we end up with a plus sign. If we have a minus, we end up with a minus sign. So generally speaking, we will get x squared plus or minus 1 quantity squared for the first term. Minus, now again, the second term is actually a perfect square because we have 2 copies of a and 2 copies of x. Meaning if we try to write as a perfect square, we have a times x quantity squared, like this. So last but not least, to factorize it, we're going to use the difference of squares to give us the following results. We have the first term plus the second term times this first term minus the second term. And this is the general results that we will have in such a setup of quartic expression. So you perhaps might wonder, does it really work for all the integers? In fact, we can see that it will not work when the coefficient of x squared is greater than or equal to 3, first of all, because in this case, we will see that after we pull out a +2 or -2, the remaining part will always be positive instead of negative, so that we have a problem of factoring it into negative something square, and then use the difference of squares to factor out. So does that mean that it will work for all other integers, meaning that it will work for any integers that are less than or equal to 2? Well, this is an assignment that I'll leave it for you guys to figure out. Alright, that's it. Thank you for watching. I'll see you guys in the next video.